Motherboard is the main component of a computer. It's basically a large circuit board where all the computer components connect to, such as the processor socket. The processor socket is where the CPU, or Central Processing Unit, is placed. There's also the memory slots, and this is where the primary memory modules, known as RAM, are inserted. And there's also the bus slots. The bus slots are used to install various components to add more capabilities to a computer, such as a video card, sound card, network card, and so on. Motherboards come in different shapes and sizes, known as a form factor. The most common form factor motherboard that is used in PCs today is ATX. ATX stands for Advanced Technology Extended. It was created in 1995 by Intel and is now the de facto standard form factor for PCs today. A full-size ATX motherboard is 12 inches by 9.6 inches. Prior to the development of ATX was the AT form factor. AT stands for Advanced Technology. This was the form factor that was used in the 1980s that was developed by IBM. AT motherboards are 12 inches by 13.8 inches in size, and they are no longer in development since the succession of ATX. Another version of the ATX motherboard is the Micro ATX. Micro ATX motherboards are smaller than ATX boards, as its name suggests. Micro ATX boards are 9.6 inches by 9.6 inches, so it's a square design compared to the standard rectangular design of the ATX. They are cheaper than ATX boards and were designed to fit in smaller computer cases. They also have fewer features and consume less power than a standard ATX board. The BTX form factor was designed by Intel to make further improvements from the ATX form factor, such as an improved board design, which creates a more inline airflow, which improves cooling. For example, notice how the memory and bus slots are horizontal, flowing with the direction of the airflow instead of inhibiting compared to the ATX form factor. Another improvement is the structure design, which is flexible enough to work in both smaller cases and larger tower cases. And BTX motherboards take full advantage of the new input-output technologies such as serial ATA, USB 2.0, and PCI Express. Even smaller than the Micro ATX and BTX motherboards, there's the ITX form factor. The ITX form factor came out in 2001, starting with the Mini ITX shown here. And this was designed for the ever-increasing demand for smaller space-saving computers. The ITX standard consumes less power, and because they use less power, they are often cooled only by the use of heat sinks, and not with fans. ITX was developed by VIA Technologies, and there are currently 4 sizes that are in the ITX form factor. There's the Mini ITX. There's also the Nano ITX, which came out in 2005 and was designed to be used in devices such as digital video recorders, media centers, and cars. Then there's also the Pico ITX, which came out in 2007. And in 2009, VIA Technologies introduced the smallest x86 CPU module specification in the industry, with the release of the Mobile ITX. The Mobile ITX measures 6 centimeters by 6 centimeters, and it was designed to provide developers with a standardized and ultra-compact specification for building new computer-based products. Another form factor is the NLX. NLX was created by Intel, and it was designed for low-end, low-profile computers. Instead of expansion cards that plug perpendicular into the motherboard, the NLX boards use a riser card. where expansion cards can plug in parallel with the motherboard. You would typically find NLX boards in slimline computer cases. One of the main and one of the most important components you'll find on the motherboard is the chipset. Older motherboards were designed with a lot of different chips scattered all over the motherboard. There were chips for different things, like chips for bus controllers, memory controllers, keyboard controllers, and so on. So they had a lot of different chips controlling different functions on the motherboard. So as technology progressed, computer engineers decided to reduce the number of chips and have them more in a centralized location. So instead of having these different chips scattered all over the motherboard controlling different functions, they reduced the number of chips to do the same job and condensed them to only a few chips, or what's now called a chipset. And that's what a chipset is. A chipset is a smaller set of chips that has replaced a larger amount of chips. And the chipset's job is to control data flow between the CPU, the peripherals, bus slots, and memory. So all of the different parts of the computer communicate with the CPU through the chipset. The chipset basically consists of two chips. One is called the North Bridge, and the other is called the South Bridge. The North Bridge is located in the upper or northern part of the motherboard, providing you're looking at the motherboard in the upright position. It's located near the CPU and is directly connected to the CPU. It's also directly connected to the memory and the AGP and PCI Express slots. So in order for the CPU to communicate with the memory and the AGP or PCI Express bus, it has to go through the North Bridge first. So the North Bridge acts like a communication middleman between the CPU, AGP or PCI Express, and memory. The other chip is called the South Bridge, and the South Bridge is located at the bottom or southern portion of the motherboard, near the PCI bus slots. The South Bridge connects to the PCI bus slots, SATA and IDE connectors, and USB ports. So the South Bridge is responsible for the lower portion of the motherboard, while the North Bridge is responsible for the upper portion. There is no direct connection between the CPU and the lower portion of the motherboard. So if the PCI, USB, IDE, or SATA ports needed to communicate with the CPU, the information has to go through the South Bridge, and then up through the North Bridge, and then to the CPU. The North Bridge is faster than the South Bridge, and that's because the CPU, the PCIe, AGP, and memory are the most used and most important components of the motherboard. So they need to operate at the highest speeds possible. The slower South Bridge communicates with the PCI bus, SATA and IDE connectors, and USB ports, and they don't need to be as fast as the other components. So basically the higher speed components are connected to the North Bridge, and the slower components are connected to the South Bridge. Now both the North and South Bridge make these connections to various parts of the motherboard using pathways called a bus. And a bus is simply a set of pathways that allows data and signals to travel between components on the motherboard. The motherboard contains several kinds of buses that vary in speed and bandwidth. So for example, if a bus speed is said to operate at 66 megahertz, then that means that that particular bus can send data at 66 million cycles per second. The higher the bus speed, the faster the computer can send data, which improves the performance of the computer. A motherboard's bus speed generally refers to the speed of the front side bus. The front side bus is the connection between the CPU and the Northbridge chipset. All motherboards are equipped with input-output bus slots. These are typically located on the bottom rear of the motherboard. These bus slots are also called expansion slots because these slots are used to expand the capability of the computer. For example, if the motherboard doesn't already have a built-in sound card, then you can add a sound card by inserting one into one of these bus slots, giving your computer the ability to produce sound. Or, let's say the motherboard doesn't have enough USB ports to suit your needs. Well, then you can add a USB expansion card in one of the bus slots to add more USB ports. A modern bus type today is called PCI, which stands for Peripheral Component Interconnect. PCI has been around since 1993 and was the standard bus slot for modern motherboards until PCI Express came out, which we'll talk about shortly. PCI slots are much faster compared to ISA slots, with a data path of 32 or 64 bits, with speeds ranging from 133 to 533 megabytes per second. They are also about half the physical size and length of the ISA slot. As computers got faster, a lot of people were using their computers for higher-end graphics applications such as gaming. And as computers became more graphically oriented, the PCI slot was lagging behind in delivering computer graphics data. For this purpose, the AGP slot was developed. AGP stands for Accelerated Graphics Port, and it was created to assist in accelerating 3D computer graphics. One of the main reasons why AGP is faster than PCI is because AGP has its own dedicated pathway to the processor, unlike PCI. The AGP port is only used for a video card and is usually a brown color. PCI Express is the latest version of bus slots. It's faster than its predecessor with speeds up to 4 gigabytes per second. And unlike standard PCI, which transfers data in parallel, PCI Express transfers data in serial. Transferring data in serial is much faster than parallel, because serial data is transferred in packets. PCI Express was designed to succeed all other PCI bus slots and AGP. And it is not backward compatible with standard PCI, because the architecture is very different. There are 4 different slot sizes in PCI Express. There's PCI Express by 1, 4, 8, and 16. PCIe by 1 has 1 lane for data. A lane has 4 wires. 2 are for sending and 2 are for receiving. PCIe by 4 has 4 lanes. PCIe by 8 has 8 lanes. And the fastest slot is PCIe by 16, which has 16 lanes. And PCIe by 16 has succeeded the AGP slot for the video card. And there is also the PCI-X slot, where the X stands for extended. The PCI-X slot is basically an extension of the old standard PCI slot, and it's almost twice the length of a standard PCI slot. The PCI-X is a 64-bit bus, and it is backwards compatible with the standard PCI slot. It was mainly designed to work with servers and high-speed computers. And there is also the mini PCI slot, and this is what is used in laptops. It's approximately 1/4 the length of a standard PCI slot. The mini PCI slot is a subset of the standard PCI bus, but it's a lot smaller. Now you can insert a regular PCI card into a mini PCI slot, but you would have to use a mini PCI to PCI converter. The mini PCI is a 32-bit, 33 MHz bus.